Bismillahirrahmanirrahim. Now we are going to start exercise 4.2, and here we have some similar question from question number 10 to 18, and these all these questions are about a smart substitution. Here we will deal these questions smartly by putting one or two terms is equal to t or any other constant, and then simplify all these questions. Now, first of all, here we have question number 10, and this question is written as I is equal to integral 1 upon 1 plus x square into tan inverse x dx. Here is x square. Now, if we see tan inverse x, if we let tan inverse x is equal to t, and we know that derivative of tan inverse x is equal to 1 upon 1 plus x square is also present in this question. So we will tackle this question smartly and write it as 1 upon tan inverse x, and the other part of 1 upon 1 plus x square is written in the product of tan inverse x into dx. Now take tan inverse x is equal to t, and derivative of tan inverse x is equal to 1 over 1 plus x square dx, and the derivative of t is equal to dt. Actually, this derivation or substitution can be solved as tan inverse x is equal to derivative of tan inverse x and the derivative of t. So tan inverse x is equal to 1 upon 1 plus x square, and the derivative of t will be equal to dt upon dx. And here we have separable technique and separating the variables. So dx is written on the left hand side along with the terms of x. So we have 1 upon 1 plus x square dx is equal to dt, and directly we can write here. So after putting tan inverse x is equal to t, 1 upon t, we have 1 upon t dt, and integral of t 1 upon t is equal to log of t plus c. So by using back substitution technique, we put the value of t, which is equal to tan inverse x plus c, which completes our results. Similarly, for question number 11, we have sin x plus cos x upon cos x minus sin x dx. Here we take if we have a look upon numerator and denominator, we can see that the derivative of denominator is present in the numerator. That's why we take denominator as t, cos x minus sin x as t, and after taking its derivative we have minus sin x minus cos x dx is equal to t. Take minus as common from left hand side. As we have a need of sin x plus cos x in numerator, so we can multiply sign of minus on both sides, and we get sin x plus cos x dx is equal to negative of dt. Put the value of t and dt, put the value of t and dx in above expression. We have minus 1 over minus dt. Instead of sin x plus cos x dx, we can write minus dt, and cos x minus sin x we will write t. So the derivative of 1 upon t dt is equal to log of t plus c. Here again we have a back substitution technique, so we will write the value of t and completes our result, which is equal to minus log of cos x minus sin x plus c. Now we have a look on question number 12 of this exercise. Question number 12 is integral sine square root x upon square root x. This question is little bit a bunny question. Here we have a short hack, which is this: if we have the if we have the angle in the expression of trigonometric function is different in the sense like we have square root x instead of x, and or in square root we have different terms instead of x, then we can solve those questions which have different terms if we take different terms as any other variable like t. I can explain it with an example. Like in this question, we have sine square root x upon square root x. This question can be solved easily if we take square root x as is equal to t. Here, take the derivative of square root x. We have 1 upon 2 into square root x dx is equal to dt. As we need 1 upon square root x dx, we need 1 upon square root x dx. So we will take extra term 2 on the right hand side, and we have 1 upon square root x dx is equal to 2 dt. Now put the value of 1 upon square root x dx and sine square root x in above expression. We have sine square root x is equal to t, and 1 upon square root x dx is equal to 2 dt. As 2 is a constant, so we take 2 uh, outside the integral and integrate in sine t dt. The integral of sine t is equal to minus cos t plus c, and here again the here again we will use the back substitution technique and put the value of t, which is equal to square root x, which completes our results. Similarly, we have question number 13, 14 and 15 are similar. In question number 13, we have integral square root e raised to power 2x plus e raised to power 3x dx. If we take e raised to power 2x as common, we have 1 plus ex dx, and e raised to power 2x can be written as square of ex, and can be written outside the square root. So we have ex dx and 1 plus ex along with square root. If we take 1 plus ex is equal to t, after differentiation it will become ex dx is equal to dt. Now put the value of ex dx and 1 plus ex as 1 plus ex as t. Oh, here is a little mistake. We can write 1 plus ex as integral square root of t and dt. After simplification, it will become 1 by 2 plus 1, which is equal to t raised to power 3 by 2 upon 3 by 2 plus c, which is again equal to 2 by 3 t raised to power 3 by 2 plus c. After back substitution, it will become 1 plus ex raised to power 3 by 2 plus c. Now next we will move towards question number 14 and 15, similar to question number 13. In question number 14, we have integral I is equal to 1 upon ex plus e raised to power minus x dx. First of all, simplify. Uh, we can remove negative sign by taking it e power minus x as 1 upon e power x. If we take LCM with e raised to power x, we will have ex upon e raised to power 2x plus 1. Here we take ex is equal to t, and the derivative of ex is equal to ex dx is equal to dt. Put this expression in equation number 1. We have 1 upon e raised to power 2x is equal to t square plus 1, and the expression ex dx can be written as dt. So we have integral 1 upon t square plus 1 dt, which is equal to tan inverse of t plus constant of integration c. Now By using back substitution technique, we have tan inverse x, tan inverse e raised to power x plus c. In question number 15, we have e raised to power 2x. Let's take question number 15 as assignment. You can solve yourself this question and give your remarks about this question. If you have any, if you found any difficulty in this question, you can ask by using WhatsApp or messaging or any other method. We will move towards question number 16. Here, like question number 13, we have cos log of x upon x dx. Here, the angle of cos is log of x, which is different than x. So, for solving this question, we can take log x is equal to t. After differentiation, log x is equal to 1 upon x dx is equal to dt. Substitute these two values in equation number 1. We have cos of t dt. After integration, it will become sin t plus c, and again by using the technique of back substitution, we will get sin log of x plus c. Similarly, question number 17 and 18, both questions are simplified by using substitution technique. Here we have in question number 17 2x plus 5 upon x square plus 5x plus 7. Along with square root, we will take x square plus 5x plus 7 is equal to t, because I can see the derivative of denominator is present in numerator. So we will substitute x square plus 5x plus 7 is equal to t, and its derivative will become 2x plus 5 into dx is equal to dt. Now substitute these two terms in expression number 1. We will have 1 upon square root 2 square root t dt. Now take t in numerator, and we will have t raised to power minus 1 by 2 dt. By using the formula of integration, we will have t raised to power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c. After simplification, we will get 2 into square root t plus c. Now put the value of t by using back substitution technique. Similarly, we have question number 18, which is equal to I is equal to integral x plus 2 upon square root of 2x square plus 8x plus 5 dx. Here, if we here clearly we can see the derivative of 2x square plus 8x plus 5 is equal to t is somehow present in numerator. For the purpose of solution, we will take 2x square plus 8x plus 5 is equal to t and check its derivative, which is equal to 4x plus 8 dx is equal to dt. Take 4 as common. We have 4 into x plus 2 dx is equal to dt, as we need x plus 2 in this expression. Here x plus 2 is present, so we will take 4 on right hand side, and we have x plus 2 dx is equal to 1 upon 4 dt. Put these values in expression number 1. We have 1 upon 4 dt upon square root t. Now by using previous techniques, we will simplify it and back substitute the value of t. This completes our result and completes our topic. Now inshallah, after some time, we will present with another lecture.